Good day, welcome to our new video. Today we will be focusing on sequence of real numbers, finding the general term. So I've compiled some few questions and the questions say find the general terms of the following. So before I begin with the solution, make sure you subscribe and hit the notification button. So the first question, number A, we are given an to be equal to this, minus 8 over 3 minus 8 over 7, 8 over 15, as it goes there and there. So now we are required to find an in terms of n. So I see, okay, we are given the sequence of fractions, but here is minus 8, so allow me to write it as 1. Minus 8 divided by 1, so that it can be fractions everywhere. So now I see that I have first term, second term, third, and fourth. So now I can see that on the first term I have a negative number, and on the third term I have a negative number, which tells me that on the set of odd numbers I will have negative numbers. So now what you can take from me now is that whenever you have a combination or signs which are alternating where the first term is negative, you will have minus 1 to the power of n. For all this minus 1 to the power of n will accommodate each and every term. For an example, minus 1 to the power of where n is 1, it will be minus 1. Where n is 2, it will be 1. And it's positive here. Where n is 3, it will be minus 1 and it's negative. Where n is 4, it will be positive, as it goes just like that. But we notice that on our numerator we have a constant. The constant is 8, so we can easily say times 8 divided by. When you check on the numerator, on the denominator, or on the numerator, we are done. So now we have to focus on the numerator, on the denominator, where we have 1, 3, 7, 15, as it goes like that. Now we have to determine if it is arithmetic, geometric, or quadratic. Now let's start with quadratic. 3 minus 1, you have 2. This 7 minus 3, you have 4. 15 minus 7, you have 8. And this 4 minus 2, you have 2. 8 minus 4, you have 4. We see that the second difference is not constant, which tells me that it is not quadratic. And again, the first difference is not constant, which tells me that it is not arithmetic. So now we have to test for geometric. For geometric, we know that r is given by t of n plus 1 minus divided by t of n. If we take term 2 divided by t1, we'll have 3 divided by 1, which will give us 3. And now we have to check for this and this. R will be given by T3 divided by T2, where we have 7 divided by 3, giving us 7 over 3. We see that the ratio, it is not constant, then it is not geometric. So now we need to find another way to get into our general term of our denominator, since we are done with the numerator. So now what we can check, we'll go back here, 1, 3, 7, 15. And you check here, you have 1. 1 won't give you enough evidence. So we'll start from 3. When we start from 3, you check on how can we find 3. On 3, we can either find 3 in this way. It can be 2 plus 1, or it can be 4 minus 1. And this 4 minus 1, we can write it as 2 to the power of 2 minus 1. And now still we don't have enough evidence. We go to 7. 7 can be given by what? By 6 plus 1, or 8 minus 1. And this 8 minus 1, it can be 2 to the power 3 minus 1. And now when you check this one and this one, when you compare them, there's no relation between them. But if you come and check this one and this one and you compare them, you see that you have minus 1 as a constant and the base as a constant. The only thing that is changing is the exponent. So I see that, okay, the base and minus 1, they are constant. I can easily come here and say 2 minus 1. And now we need to determine what's going on with the exponent. On 3, we know that 3 is the second term of our what? Denominator. And here the exponent is 2. Second term and exponent is 2. And say, okay, let's wait a minute and check for the next one. 7 is the third term of our denominator. And since 7 is the third term and also the exponent of these two is 3, which means that the exponent corresponds with the number of term. And now we have enough evidence to say here is 2 to the power of n. That's the general term. We are done with this one. So you can check minus 1 times 1, it will give you minus 1 times 8, it will give you minus 8. Then 2 to the power of 1 will give you 2 minus 1, giving you 1. Then minus 8 divided by 1 is this one. Then you can check other terms. So now let's go to B. For B, you are given B of n to be equal to the sequence of 1 over 2, 7, 1 over 8, 11, 1 over 32, 15 as it goes there and there. So now we check. We need to determine Bn in terms of n. And now when we check, here we have combination of fractions and integers, positive integers. So okay, I see. This is term 1, this is term 2, this is term 3, this is term 4, 5, 6. And now I see that, oh, term 2 is 7, is an integer. Term 4 is 11, is an integer. And term 6 is 15, it is an integer. Which tells me, oh, the set of integers, the set of even numbers is given by what? By the sequence of integers. But the set of what? Of odd numbers is given by what? By fractions. So which in conclusion I can say it's a combination of two sequences, fractions and integers. So I can divide them into 2, and this tells me, oh, it's a piecewise function, which means we need 2 general terms here. So first I will focus on this one of integers. Integers, we have 7, 11, 15. So since 7, 11, 15, they are on the set of even numbers. We know that even numbers are represented by 2 to the power of n. And we check, can 7 be given by 2 to the power of n? N is 2, which means you'll have 4. For this one of 11, n is 4, you'll have what? 2 times 4, you'll have what? 8. And this one of 15, you have 6. 2 times 6 is 12. And we say, oh, 4 is not the same as 7, 8 not the same as 11, and 12 not the same as 15. And then these 4, 8, 12, they're represented by 2 to the power of n. And now we check, can we find any constant that if we add to 4, 8, 12, we'll get the corresponding 7, 11, 15? And you ask yourself, 7 is given by 4 plus 3. 11 is given by 8 plus 3. 15 is given by 12 plus 3. And you say, oh, now it's clear that B of n will be equal to 2n plus 3. Since we know 4 represented by 2n, 8 by 2n, and 12 by 2n. For n equal to 2, 4, 6 of when n is even. And then now, we are done for even. And now let's focus on the what? Denominator. We have 1 over 2, 1 over 8, 1 over 32. When we focus on odd numbers, you see, denominator and odd numbers sometimes are confusing. It's like it's one thing. So yeah, so 1 over 2 on the first term, 1 over 8, 1 over 32 is the set of what? Of odd numbers. So okay, 1 over 2 is what? Is term 1. 1 over 8 is term 3. 1 over 32 is term 5. And I say, okay, let me see. Since term 3 is 1 over 8, term 5 is 1 over 32, and term 1 is 1 over 2. I can say, oh, here it can be 2, 1 over 2 to the power of 1. But here, since 1 on the numerator you see is constant, which means somewhere you'll have 1 divided by. Now let's focus on the denominator. You have 2 to the power of 1. Can we write 8 in terms of 2, of base 2? Yes, it can be 2 to the power of 3. 32? Yes, it can be 2 to the power of 5. So now you check. When n is 1, you have 2 to the power of 1. When n is 3, you have 2 to the power of 3. When n is 5, you have 2 to the power of 5. Which means, oh, the base of the denominator is the same. But the exponent changes as the number of terms changes. And they correspond. Which means here I can easily say n. When n is odd. That's the solution for B. So C, we are given that we have C of n to be equal to 0, 1, 0, 1 over 2, 0, 1 over 3 as it goes there. Okay. Now, we need to determine C of n in terms of n. And when we check, this is the first term, second, third, fourth, fifth, sixth. So now we check. First term is 0. Third term is 0. Fifth term is 0. And it is the set of what? Of odd numbers. And it is constant. It's just 0. But the set of even numbers or even terms is what? It's a fraction. 1, 1 over 2, 1 over 3. Because we know that 1 can be 1 over 1. So I said, oh, it's a piecewise function, which means I will need to have 2 functions. But the one already is obvious because you've seen it is constant and it is 0 when n is what? Is odd. And now we have to determine this one. This is comma, not 1, negative 1. We have 1 divided by 1, 1 divided by 2, 1 divided by 3. And you ask yourself, the first term you have 1 divided by 1. Fourth term, 1 divided by 2. Then 6, 1 divided by 3. What do you see? And then now, what you can check, you have what? 1 divided by 1. And if you check, the numerator is constant, which means somewhere you will need to have 1. Somewhere you will need to have 1 as the numerator. And then let's check the denominator. We have 1, 2, 3. But it's 1 when n is 2. It's 2 when n is 4. It's 3 when n is 6. And we say, what do you see? When n is 6, it is 3. And 3 is the half of 6. When n is 4, it is 2. And 2 is the half of 4. When n is 2, is 1. And 1 is the half of 2. What does it tell you? In order to get these 3, you'll say n divided by 2. Because you'll have 1 divided by 6 divided by 2. Which will be 1 divided by 3 for this one. And I say, oh, okay. And now what can you do? You can simplify further and say 1 multiplied by, it was n divided by 2. Now it will be 2 divided by n, which will give you 2 over n. And say, oh, it will be 2 divided by n when n is even. Done with the third one, just like that. So now, the last one, D. D, you are given D of n, set of or sequence of 1, 2, 1 over 9, 4, 1 over 25, 6, 1 over 49. As it goes there and there. So now we check. We need to find t of n in terms of n. And now we check the given sequence. Is it arithmetic, geometric, or what? You can check all these things. But now I see it's a combination of positive integers and positive fractions. So I can easily say, oh, since it's a combination of 2, then it means it's a piecewise function. And then now I can check. You have 4, 6. This is first term, second, third, fourth, fifth, sixth, seventh. And now you check. Fourth term is 4, sixth term is 6, which means the set of what? Of even terms is made up of integers, which means even these two will be part of set of integers. So now I say, oh, okay, set of even terms is integers, and the set of odd terms is fractions, which means I can write 1 over 1 just like that to make it fractions to avoid confusion. So now I can start with what? With the set of integers. When you check the set of integers, you have 2 is the second term and it is 2. I said, oh, what's going on here? Let's go to the next one. It's 4 and the nth term is 4, which means, oh, it is 4 when n is 4. And here it's 6 when n is 6. What does it tell you? It tells you the set of integers is given by the function n when n is even. Because you can easily see n2 give you 2, n4 give you 4, n6 give you 6. Then it's n. And then now we focus on the fractions. You have 1 over 1, 1 over 9 when n is 3, 1 over 25 when n is 5. You see, 5 can go to 25, 3 can go to 9, 1 can go to 1. And say, oh, let me check this one. 7, and it's true. 7 can go to 49. And say, oh, you can write these things like 1 to the power of 1. I mean, yeah. For now, let's say to the power of 1. I say, oh, since 3 can go to 9, I can write this as 3 to the power of 2. 5 can go to 25. How many times? Okay, 5 can go to 25. Okay, I can write it as 5 to the power of 2. And this one, 7 to the power of 2. And say, oh, I see the exponent is constant, is 2, 2, 2. Which means even here, I can write to the power of 2, 1 to the power of 2, which is still 1. And I say, okay, the numerator is constant, 1, 1, 1, 1. And I say 1 divided by. When you check, the base changes, 1, 3, 5, 7. But the exponent of the base is constant, 2, 2, 2, 2. And say, oh, why is it that the exponent is constant but the base changes? Why is it the base changing? And now let's check. When n is 1, the base is 1. When n is 3, the base is 3. When n is 5, the base is 5. So these things correspond to n, which means I can easily say n, and the exponent remains the same, is n squared. When n is odd. This is how I solve the questions. So thank you. Subscribe for more so that I can know. If you don't subscribe, I will no longer post videos. But if you subscribe, I will continue posting videos and give you content. Thank you.